In this lecture, we will study about I/O programming, string-oriented instructions. The string-oriented instructions are mainly used with the help of SI, the source index, TI, the destination index registers. That is, a data is moved from source to destination, and the source and destination are identified by an address which is contained by the in the SI and DI registers. There are a number of string-oriented instructions, and they are either based on byte or word. Many of the string-oriented instructions will end with the letter S. S followed by B means it is a byte-oriented instruction. S followed by W means it is a word-oriented instruction. But if S not followed by any letter, it may be byte or word-oriented instruction. It is known by other parts of the instruction. In addition to the string-oriented instructions, we will also study about I/O programming in this lecture. In the case of I/O programming, there are basically three modes. The first one is the programmed I/O mode. The second one is the interrupt initiated mode. The third one is DMA mode, or direct memory access mode. In the case of the first two, it is done by means of a simple program, and correspondingly the program takes a reasonably long time because it is required to get an instruction from memory, then execute the memory. The number of instructions may be one or more than one. In the third approach of DMA, what we normally do is we transfer a large number of bytes in one sequence, maybe 1 or 2 kilobytes of instructions. Once the data flow starts, it continues uninterrupted. However, we will concentrate on this in this lecture only the first two modes of data transfer, that is programmed I/O as well as interrupt initiated I/O. The DMA will take up in a later lecture. In this lecture we will talk about byte and string manipulation and I/O programming. The first one is we will take the instructions which are related to the strings, what we call as string-oriented instructions. There are a number of string-oriented instructions in the microprocessor 8086 instruction set. String instructions can operate on only byte or word, and hence REP prefix is used to manipulate long strings of bytes or words. String instructions are called string primitives. All string primitives are 1 byte long, with bit 0 indicating whether a byte is involved, that is bit 0 is 0, or a word is involved, that is bit 0 is equal to 1. Some of the string manipulation instructions are move S DST comma source, that is move the string from source to destination. What exactly happens is, when this instruction is executed, the SI is used as an address, then the contents of that address are moved to the contents of the address represented by DI. That is, the contents of SI and contents of DI are used as addresses, and the contents of the location where SI points are moved to where DI is moved. Now, for byte operands and for word operands, the execution is slightly different. After moving, for byte operands, SI is incremented or decremented by 1. Similarly, DI is incremented or decremented by 1 based on other parameters, which we will discuss later. In the case of word operands, SI is incremented or decremented by 2, DI is incremented or decremented by 2. The incrementation or decrementation depends on the direction flag. Then the same instruction can also be written as move SB for bytes, move SW for words. The operands are determined by the contents of SI, DI, DS and ES registers. The source operand is obtained by the contents of the sum of SI and DS multiplied by decimal 16, that is the contents of source index register and the contents of data segment register multiplied by decimal 16. The address of the destination operand is obtained by the sum of the contents of DI, that is destination index register, and the contents of ES, that is extra segment register, multiplied by decimal 16. This addressing scheme implies that the offset of the source or destination operands must be put in the registers SI and DI before the instruction is executed. In addition to performing the indicated operation of moving the contents of source operand to destination, the instruction causes the contents of SI and DI to be decremented or incremented by 1 or 2 based on the contents of the directional flag DF and based on whether it is a byte or word oriented instruction. If the directional flag DF is 0, the registers SI and DI are auto incremented, and if DF is 1, the registers are auto decremented. The incrementing and decrementing is by 1 for byte oriented operands and 2 for word oriented operands. Let us see one more instruction. Now we will take up the instruction related to compare. It is CMPS SRC comma DST. That is, this is a comparison instruction. The comparison is done by subtracting the contents of SI, subtracting the contents of DI from SI. In the case of byte oriented operands, after the subtraction is performed, SI is incremented or decremented by 1, DI is also incremented or decremented by 1. Similarly, in the case of word operands, SI is incremented or decremented by 2, DI is incremented or decremented by 2. There are also two more instructions, CMPSB and CMPSW. These are similar to CMPS, except that here whether it is a byte oriented operand or word oriented operand is clearly present in the instruction. The operation is the contents of destination are subtracted from the contents of source, and it affects all the condition flags. Regarding the addressing and other details, it is exactly same as the previous instruction, move S. Let us take one more instruction, SCAS DST. The operation of this instruction is that the contents of destination are subtracted from the contents of either AL or AX register, and the directional flag is incremented or decremented by 1 or 2. The execution of this instruction affects all conditional flags. As you can see, SCASB, SCASW, both are there. That is, one is the byte oriented one, the other one is the word oriented one. The operation is the subtraction. It is common in the case. In the case of byte oriented one, the register is AL. In the case of word oriented one, the register is AX. Let us see one more instruction, LODS SRC. This may be read as load source. The operation is that the contents of the source register is added to the contents of the DS register multiplied by decimal 16. The contents of this address is loaded into either AL or AX depending on the byte or word oriented instruction. So here we have byte oriented as well as the word oriented instructions. The first one is byte oriented instruction, the second one is word oriented instruction. Flags are not affected in this case. The next instruction is STOS DST, that is store destination. So this also has two versions, STOSB, STOSW. The operation of this instruction is the contents of the address calculated by adding the contents of DI register to the contents of ES register multiplied by decimal 16. Then they are loaded with the contents of AL AX register. That is, the contents of a specific address are loaded into the AL or AX registers. This implies that the contents of AL AX register are stored in memory at a specified location. Flags are not affected. Now let us see the advantages or disadvantages of MOVS CMPS instruction over the conventional MOV and CMP instructions. Because we have conventional MOV and CMP instruction, they are applicable only for one operand. MOVS and CMPS are applicable to string oriented instructions. The advantage, as you see, is these are only 1 byte long. Then both operands are memory operands, whereas in the conventional instructions both operands from memory is almost impossible. Most of the instructions are only one operand from memory, other operand is register. Then auto indexing removes the need for separate incrementing or separate decrementing instructions. Hence, it decreases the overall processing time.